Praxis energy is practical energy. What could be more practical than using one of nature's most fundamental forces, gravity, to generate electricity? We have developed a very unique and innovative way to harness the force of gravity to provide very low-cost electricity to be used in distributed generation. Unlike wind or solar, gravity is with us 24/7, 365. Of course, using gravity for generating electricity is not new. At Hoover Dam, we've been generating electricity since 1934. And as long as the water is running, there is no fuel cost. Gravity of falling water is the prime mover. Generating electricity is not the only way gravity is used for work. The counterweight of a pump jack helps to lift oil from deep wells. A crane uses gravity to stabilize its lift of heavy loads. And a wrecking ball is a wonderful example of the kind of force that we will capture for our system. In our system, we are reviving a very old concept: use of a pendulum for work. A swinging pendulum was one of the tools of the trade in the 15th and 16th centuries. We have found several illustrations in older publications of pendulums assisting in sawing timber, pumping water, pounding metal, or operating a bellows in a giant forge. Leonardo da Vinci left us lots of drawings of pendulums. Why use a pendulum? Its mechanical advantage. With a mechanical advantage, we put in a smaller force that we extract. It's not perpetual motion. We're just taking advantage of the restoring force created by the acceleration due to gravity. When you displace a large weight, suspended on a rod to one side, and let it oscillate on a rod fixed to an axle, the weight generates a significant force every time it oscillates. And that swinging of the pendulum looks like this. The weight of this pendulum is 9 tons, and the rod is 18 feet long. The energy is harvested from the torque created as the shaft turns. The pendulum is acting as a giant lever. The momentum of the pendulum is maintained by a periodic impulse that compensates for any slowing of the pendulum that is created by the load being applied and the friction lost in the system. The Praxis system used the pendulum as its prime mover. However, we use a proprietary set of gears to translate the oscillating motion of the axle to a continuous rotary motion. Then we add speed-increasing gears to provide the proper rotational speed for an electrical generator. We have a creative patented method of providing the periodic impulse that maintains the momentum of the pendulum. The impulse wheel is driven by a motor in its hub. The motor can be powered by a battery, electricity from the grid, or a portable generator. In smaller systems, it could even be powered by humans. For remote locations, the battery can be recharged with solar panels to make it work completely off the grid. We have built a working model of the front part of the system to measure its mechanical advantage. With this model, we can vary the input weight, the length of the rod, and how much load is being applied. To measure the forces, we used a simple mechanical torque meter. The measurements we obtained are good approximations, but not sufficiently accurate to begin to engineer an automated system. We also built our unique impulse wheel. Put a torque meter in between the crank and the push on the pendulum handle. This allowed us to measure the input force and compare it to the output torque being generated. Our garage level model provided positive data results sufficient to go to the next step. Our job now: rebuild the garage model with electronic measuring devices so that the result can be considered more scientifically accurate, and we have good data to engineer the whole system. Then we will build a working prototype of the full generating system, sufficient to demonstrate all of its components. Thank you for your interest and for your support.